Now we'll look at the practical problems in union and intersection. And before we go ahead, let me remind you that this A minus B is this portion, B minus A is this portion, and A intersection B is this portion. So these three are disjoint. They have nothing in common. First, I would like to take you to the actual expression, which is this. Please understand that this is n. We are talking about number of elements. So the number of elements in A union B is equal to NA plus NB minus NA intersection B. This is the expression. We are going to show it also. But before we go ahead, let me tell you that if this intersection is nil, that is, there is no intersection, then we go back to this expression. That is, if A and B are disjoint, they have nothing in common, then we say that A intersection B, number of elements, will be equal to exactly NA plus NB. Now let us give you an idea how this actually came up. And before that, let me remind you that A minus B, A intersection B, and A, B, and B minus A, they are disjoint as we just saw in the Venn diagram. So NA union B is equal to nothing but, what was that? These three additions, means this part, this intersection part, and this part. So we add them. Let us add them. And now we are aware that this is the expression. Let us add it. So NB and B minus A. And what we are going to do is, we will add NA intersection B and subtract A intersection B to this expression. We want this expression to come. So what will happen? Let us cancel these two out. So exactly what we got is this expression, NA plus NB minus NA intersection B, and this is what we wanted. So by the Venn diagram, we took forward our step and then added and subtracted this value, and then this is the expression. So this we extend to three sets, A union B union C. If we want to find out the number of elements in A union B union C, that will be NA plus NB plus NC, and we will subtract A intersection B, B intersection C, A intersection C, and meanwhile we have subtracted the element which are way higher, so we need to subtract this also, or add this also. By doing this, we have subtracted A intersection B intersection C, so we will add this. So this formula you have to learn by heart, and this is the explanation. I hope you will be able to understand this, how we have got this, because there is a distributive law. A intersection B union C is equal to A intersection B union A intersection C. This is what we have used, right? We'll straight away go to the question. This question is X and Y are two sets such that X union Y is 50 elements, X is 28 elements, and Y is 32 elements. So how many elements does X intersection Y we have? So we know that the formula is this X union Y is equal to X plus Y minus X intersection Y, and everywhere we are talking about the cardinality or the number of elements in this set, and which is given to us in the question. Just place the value 28 plus 32 minus 50, that will be 10. This is our answer. The next one is, in a school there are 20 teachers who teach mathematics or physics. Whenever you see this or, just understand we are talking about union. Then the second part is 12 teach mathematics and 4 teach both physics and mathematics. Where this n comes, that means we are talking about the intersection. 20 is will name the set as M and P, M for the mathematics, P for physics, the initials of mathematics and physics. So M union P, as it is given, is 20. It is given M mathematics is 12. It is also given 4 teach physics and mathematics. N means intersection. So M intersection P is 4. We'll use this formula. We know by now that this formula directly we can place the value, and NB will be 12. So 12 teacher teach physics. Next is, there is a class, 35 students are there. 25 like to play cricket and 16 football. So 24 is NX, we say X for cricket, Y for this football, so NY is 16. Intersection Y and union Y, X union Y is 35, because we know that in all 35 students are there. And then X intersection Y is what we need to find out. We'll use the formula directly, and X union Y is equal to NX plus NY minus this nx intersection y, and this will give rise to 35 is equal to 24 plus 16 minus nx intersection y. That will be our final answer, and which will be your 5. So 5 students like to play both games. Next, in a survey, 400 students they are in schools. So we are talking about a universal set where we have 400 students. 100 were listed as taking apple juice. 100 take apple juice. 150 take orange juice. 75 take both apple and orange. So n intersection A and B is 75. N universal is 400. This NA, if you say for apple, we take A. So NA is 100. NB is 150 because we take B for orange juice. And now we have to find out how many students who are taking neither apple nor orange juice. So actually we have to find A intersection B intersection, A complement B intersection, and intersection of this A complement B complement intersection. So we need to find this. This is what the question has been asked. So what we'll do is N A intersection B, A complement intersection B complement is nothing but N A union B complement. How did we reach this? This is by the De Morgan's law, and this we know very well that if you subtract this NAUB from the universal set, you will get the complement of A union B. But we know that A union B is nothing but NA plus NB minus NA intersection B. And we'll just revert the sign because the sign is minus. So we'll place the value 400 minus 100 minus 150 plus 75, and that will be 225 students. So there are 200 individuals. Next question, 6 skin disorder. 120 has been exposed to chemical C1, 50 to C2, 30 to both C1 and C2. So this is their intersection. We need to find the number of individuals which are exposed to C1 but not C2, C2 but not C1, and C1 or C2. So this is very clear, C1 or C2. That means we want to find out the union that we will be finding later. But U is the universal set. C1 will denote it by A, C2 will denote it by B. So NU is 200 as it is given, NA is 120 as it is given, and B is 50. We take C1 A, C2, this is 50, and A intersection B is also given as 30. How? This is given both C1 and C2. For the first one, we want the A which is in C1, which is exposed to C1, not in C2. So here in this Venn diagram, you see A is nothing but A minus B union A intersection B. So A minus B union A intersection B. So let us take n both the sides. You have to use this expression. Let us take n both the sides, n equal to n A minus B plus n A intersection B, and we know that A minus B and A intersection B are disjoint. So we are not going to take that minus aspect. So we'll place the value directly, 120 minus 30, that will be 90. So those values, those number of individuals which are exposed to C1 not to C2 are 90. Again for B, same logic will use. B minus A union A intersection B. We'll take n both the sides. We'll not take that minus of these two intersections. Why? Because these two are in disjoint set. You have to understand this Venn diagram very clearly. Otherwise, you will not be able to understand what I am speaking of. Otherwise, we need to add that plus. We'll not be adding it because these are disjoint. So let us take directly the value. NB is 50 and A intersection B is 30. That will be 20. So your answer will be 20. And the third part is quite easy. You just have to find out the union. So place the value directly, 120. This is 50 minus 30. That is 140. So the number of individuals exposed either to C1 or to C2 are this. Next is the miscellaneous example. So we will take this, show that the set of letters needed to spell cataract and the set of letters needed to spell tract are equal. Let us make a set, CATR. We are not including the duplicates. Then tract, TRACT. Again, we will be taking only one T. TRAC, CATR, both sets have exactly same element. The order are different. And we have known by now that the order doesn't matter. But the things which matter is the content should be same. So we declare that these two are exactly equal. These two are equal set. Next is list all the subsets of the set -1, 0, 1. A is -1, 0, 1. You know that if these are three elements, we'll take 2 to the power of these number of elements. How many are there? 3. So how many sets of this or subsets of this set is going to be there? It will be 2 to the power 3, that is 8. When you make the subset, just count. It should be 8, otherwise you are doing something wrong. And we'll make. First we'll take the individual element -1, 0, 1 like this, -1, 0, 1. Then we'll take the combination of 2, -1, 0, 0, 1 and -1, 1. This is our combination. Then we are going to take one more. The complete one is also the subset, this one. One more is left. We have gone up to 7, and the final is the empty. Empty set is the subset of every set in this world. Now next comes is A union B is equal to A intersection B implies A is equal to B. How are we going to do that? Let us assume that we have some A which belongs to A. If A belongs to this capital A, it is surely going to belong to A union B also, because A is already there. But we know that A union B is A intersection B as it is given in the question. So we can replace A union B by A intersection B. So A belongs to A intersection B also. That means if A belongs to A belongs to A intersection B, that means A should belong to B also, because intersection means the common values. This implies A is a subset of B. Let us take one more, B, and we'll start from this side. B belongs to B, this small b belongs to B, and B belongs to A union B. We know that B belongs to A union B because A union B is nothing but the combination. But we know that A union B and A intersection B are equal, it is given. So B belongs to, we'll replace A union B by A intersection B. So B belongs to A intersection B. So that means if B belongs to A intersection B, B has to belong to A also, B has to belong to B also. So B belongs to A. This means B is a subset of A, which eventually gives A is equal to B. Now we have one more example. For any set A and B, show that P intersection B is PA intersection BB. Please understand, this is a power set. This is not a normal set. This is a power set. So let us assume that we have a set. See, X we have used capital. So X is a set which belongs to power set of A intersection B. We know that it belongs to power set. That means it is a subset of A intersection B. That means it is a subset of A also. It is a subset of B also, because intersection sign is there. So we know now by A, X should belongs to PA power set of A, and X should belong to power set of B, which is actually implying that X is belonging to PA intersection PB. If it is belonging to both of them, that is X is belonging to PA intersection PB also, which gives that PA intersection B, because X was belonging to this, and eventually we fed that it is belonging to PA intersection B also. We finally say that PA intersection B belongs to PA intersection PB. Now let us move on the opposite side. Let us assume Y belongs to this one. Y belongs to PA intersection PB. That means Y actually belongs to PA and Y actually belongs to PB. This means Y is a subset of A and Y is a subset of B. That means Y is a subset of these two intersections, A intersection B, which is actually implying Y belongs to power set of AB. Y subset means Y will be belonging to power set of A intersection B because it is power set, which gives that PA intersection PB is a subset of PA intersection B. So in both the cases, we have assumed and we have realized that PA intersection B is equal to PA intersection PB. So this we are going to take in the next discussion, and then we will try to revise what we have learned in the whole lesson. Thank you so much. Take care of yourself.